Okay, you have any questions about it? Okay, let's try to do that homework. Can you read most of it? You can probably read most of it, I would think. Okay. Go ahead. Mm-hmm. Okay. Their T is the angle. Okay. Do you know what angle that is? Pi over 3? In degrees? I'm going to assume that you're still more comfortable talking in degrees than radians. So I would suggest that let's convert stuff to degrees until you get so you're comfortable thinking and talking in radians. So what is, we know that's an angle because it's got pi in it. When you see a pi, it's got to be an angle. Okay? It doesn't have to be, but it is. So what is pi over 3 in degrees? Remember the relationship, the denominator under the pi times the degrees has to equal 180. Yeah, 60 times 3 is 180. So we're looking at, here, let's first of all draw our unit circle. And they want to know what that is, that xy coordinate. Well, what do we know about that xy coordinate? What's x equal to? X is equal to a trig function of that angle, and y is equal to a trig function of that angle. What is it? X is what? This is on that page that I gave you to memorize. X is the coat. Okay, so X is what? No, X is the cosine of that angle. Well, let's forget for a moment. Yeah. No, you're right. The answer is 1 over 2. But it's important that you know that the x coordinate on the unit circle is the cosine of that angle. Not just that it's 1 over 2. It's nice that you know that. I'm glad you know what the cosine of 60 is. But first of all, you have to know that x is the cosine of whatever angle they're talking about here. What is y? Yep, sine of 60. So x is 1/2 because cosine of 60 is 1/2. What's y? Yep. So that's what they mean when they want you to find that point. Is no matter what angle they give you, they're basically asking you what's the cosine of that angle and what's the sine of that angle. Okay? Okay, let me erase this. Give me the next one. What quadrant is that in? Well, first of all, let's go ahead and translate it to an angle. Now, there's 2 ways to do this. You can use the conversion ratio, which is 180 over pi, or you can figure out what pi over 4 is, which is easy enough to do, and then just multiply that by 5. What's pi over 4? What's 5 times 45? Okay, here, let me help you here. The 5 times the 4 is 200, right? So it's 200 plus 25. Okay, which quadrant is that in? Right, because that's 90, that's 180, that's 270. So 225 is between 180 and 270. So it's that 45-degree angle right there. And that is the angle, 225 degrees, or 5 pi over 4. And again, this point right down here, that is what in terms of sine or cosine? What is the x-coordinate? Of good. And the other coordinate is the sine of 225. So we have to answer those. Okay, so here, let me make a little writing room here. First of all, let's take the cosine of 225. Now you remember how I did this? I put in parentheses, I put the equivalent first quadrant angle, which also happens to be that, you're familiar with the term reflex angle? They haven't taught you that? Well, let's just talk about it for a second, because they're liable to talk about it with you. The reflex angle is the angle that the ray makes with the x-axis. That's 45 degrees right there. You see where I'm writing? Okay, which makes the whole angle 225. So when they're asking for a reflex angle, it's the same thing as me saying, what is the equivalent first quadrant angle? And to find those, you always do theta minus 180. Remember, if it's in the second quadrant, it's 180 minus theta. And if it's in the fourth quadrant, it's 360 minus theta. So we're in the second quadrant, so we're going to use that. So what is the reflex angle, or if you prefer, what is the equivalent first quadrant angle? They're the same. You use the equation theta minus 180, and they've given you theta. What's theta? Nope. Theta is 225. T is 225. We're going to convert it to the reflex angle, which is 45. We do that by plugging in 225 in for theta. 225 minus 180 is 45. With me? It's cosine of 45. These are the ones you really want to memorize, so you don't have to always refer back to those two triangles to figure it out. You know what the cosine of 45 is? Let me draw one of those triangles, the only one you need for 45-degree angles. What are the dimensions of that? What's opposite to 45? I call these my unit special triangles. Why do I call them my unit? It's like the unit circle. It's called the unit circle because the radius is 1 no matter where you're at on the unit circle. It's a radius of 1. So I call this the unit special triangle. And what I mean by that is the side opposite the smallest angle is always 1. Well, if that's 1, that's also 1. And if they're both 1, that's root 2. Now tell me the cosine of 45 degrees. Okay, now, has your teacher given you enough information yet to know whether you need to rationalize that or not? Has he told you he doesn't need you to rationalize these? Well, you got two choices. there's one choice. But if I rationalize it, that becomes root 2 over 2. Now, most mathematicians prefer that kind of an answer because it's got a rational denominator. This has an irrational denominator. They are both the same number. So either one of them is the proper number. But it all depends on your teacher. As I said, most trig teachers don't really care whether you rationalize it or not. And we'll get to that later. There's a real good reason why they don't care. Okay? It's easier to leave it unrationalized. So I put the answer down as 1 over root 2. Now that's the x-coordinate. What's the y-coordinate? Okay, but more importantly, it's the sine of 225. Now, first of all, let's go back. We got 1 over root 2 for the cosine, right? But we didn't put a plus or minus sign on that. What is it in the third quadrant? Correct. Also notice that ray. The x-coordinate is to the left of the y-axis, so we know it's negative, right? We can see that it's negative. And the sine of 225, we do exactly the same way. That's the equivalent of a 45-degree angle. Sine of 45 is 1 over root 2. And in the third quadrant, what is its sine? Negative. Okay, now I want you to pay attention to this point right there. See it? What's the x-coordinate? Is it positive or negative on that? Don't think anything else. Is it positive or negative? What's the y-coordinate? Is it positive or negative? You can always figure out the sign by just doing that. In other words, if I have a ray up here, what's the x-coordinate? Positive or negative? What's the y-coordinate? Positive or negative? Yeah, that's why it's all students take calculus, which does give you a nice acronym to memorize it, but you don't really need it if you're kind of picturing a unit circle, and you can see that in the third quadrant the x-coordinates are always negative, the y-coordinates are always negative. In the second quadrant, no, the y-coordinates are always positive. In the fourth quadrant, the x-coordinates are always positive, right? I mean, I go to the right. So the x-coordinate there is to the right of the y-axis. That's a positive number. And the y-coordinate is negative. That's why cosine is positive and sine is negative in the fourth. It's another one. Okay, now this time I'm not going to draw the unit circle. Okay, first of all, let's figure out what angle that is in degrees. Pi over 3 is what? I think the easiest way to do these is if you memorize what pi over 2, pi over 3, pi over 4, and pi over 6 is. Once you have those memorized, then these are easy. What is pi over 3? If pi over 6 is 30, what's pi over 3? Yeah, what's 5 times 60? 300. You do 5 times 6. That's 30. Add the 0, you get 300. Okay? So what this question is really asking is what? Forget the unit circle. Forget their x and y. We know that the x-coordinate is what? What trig function? So they're asking us what is the cosine of 300 degrees, and then they're asking us what's the other trig function? sine of 300. So that's really the question. What's the cosine of 300 and the sine of 300? Well, what's the equivalent first quadrant? First of all, what quadrant are we in at 300 degrees? Okay, apply the formula in the fourth. What's the formula say? Yes, it's the same as the second, only it's 360 instead of 180. Same as the second in terms of the formula. And then the only difference is in the third quadrant, it's theta minus 180. So the second and the fourth are relatively easy. So our first quadrant equivalent is that. It's cosine of 60. Just keep doing these. You'll memorize it eventually. The only ones you have to memorize are the first quadrant ones, because every other angle can be stated in terms of a first quadrant angle. So if you can memorize these trig functions of 30, 45, and 60 in the first quadrant, you're home free. You just got to memorize the cosine and the sine. Okay, and what is its plus or minus sign? Fourth quadrant. All students take calculus. And the cosine is the x-coordinate, and we know the x-coordinate is positive in the fourth quadrant. So that's a plus. Okay, now let's talk about the sine of 300. What's the equivalent first quadrant angle? What's the sine of 60? And what is its plus or minus sign? There you go. That's the x-coordinate. That's the y-coordinate. So if I'm drawing that on the unit circle, I've got my ray coming down like that. They're talking about that angle, which is 5 pi over 3 or 300 degrees. And that's my unit circle. That point right there has an x-coordinate of 1/2, which makes sense with our diagram. And it has a y-coordinate of minus root 3 over 2. That's what they're talking about. But really, it boils down to finding the cosine and the sine of all of these angles t. You still there? My phone kind of beeped at me for a moment. I don't know why, but... Okay, erase it. Let's do more. What else should we got? Okay. First of all, let's translate that to a degrees. And that's why I'm using bracket, because this is not the first quadrant angle. This is the angle, pi over 3. What is that? Okay, and it's 60 in all three cases. So it is the first quadrant angle. Okay, good. It's the sine of 60. What's its plus or minus sign? Right, because the original angle is a first quadrant angle. Hence the A, all students. A means all trig functions are positive in the first quadrant. What's cosine of 60? That's also plus. And what's the tangent of 60? Now, you have two ways of figuring out the tangent of 60. First of all, the tangent is sine over cosine. So I could just do square root of 3 over 2 divided by 1/2. Right? Or I could use that 30-60 triangle. But in order to use this triangle, you've got to know the dimensions of it. Well, the dimensions of the 30, this is the 60. The 30, opposite the 30 is what? It's called a unit triangle. 1, always 1, opposite the smallest angle in the triangle. Whether it's a 45-45 or a 30-60. 1 is always opposite the smallest angle. Root 3 is opposite the 60, and 2 is the hypotenuse. So tell me what the tangent of 60 is just based on the diagram. Good. What's its plus or minus sign? All trig functions are plus in the first quadrant. Now, let's say we did it the easier way. Let's put the sine over the cosine. Well, the sine is 3/2, square root of 3 over 2. And the cosine is 1/2, right? There's sine over cosine. How do you do that? How do you divide the top fraction by the bottom fraction? By what? You don't just multiply them. They're being divided right now. You just can't turn division into multiplication like that with one step. Right. In other words, I'm going to multiply by the reciprocal instead of dividing by the fraction. So it's really root 3 over 2 times 2 over 1. Now notice the 2's cancel, and I'm left with root 3 over 1. Same thing I get doing it the other way. Only this is probably a little bit faster than drawing that triangle, labeling it, and figuring out what the tangent of 60 is. So I would say on all of the problems with this problem, where you're going to have to do sine, cosine, and tangent, let's use that. Let's use instead of figuring out what tangent is from the triangles, let's figure it out what it is from the fact that we know that tangent of x equals sine of x over cosine of x. That's one of your most important identities to memorize. There's going to be a bunch of them. Trig is full of stuff that you have to memorize. But that's good. You can memorize stuff. You're going to have to get through trig. It's all about memory. Okay, so what's the other one? The other T angles that we're going to have to figure out. Sine, cosine, and tangent. Negative 5 pi over 4? Correct? Okay. Again, let's turn that into an angle in degrees. So when I put brackets, that merely means the same angle, only in degrees. When I put parentheses, it means the equivalent first quadrant angle. I'm going to do both on here. Let's start with how many degrees this is. What's pi over 4 again? And what's 5 times 45? So we're talking about a 225 degree angle in all of these. What quadrant is that in? Okay, so give me the equivalent first quadrant angle. Remember, all of these are going to be either 30, 45, or 60. One of those three numbers. There's never going to be a case here where it's going to be 40 degrees or 50 degrees because we're not taught those. They're not having you use a calculator. If you could use a calculator, you just stick it in, minus 5 pi over 4 in radians, and you'd have your answer. They don't want you to do it that way. They want you to do it this way. So, what is the sine of 45 degrees? Think of that 45-degree triangle. Okay, that's fine. I don't have any problem with that answer. That's rationalized. In other words, my answer would be 1 over root 2. Same thing. What is its plus or minus sign in the third quadrant? Okay. It's cosine of 45 degrees. What is its plus or minus sign? And what's the tangent? Put the sine over the cosine. So we got minus root 2 over 2 divided by minus root 2 over 2. Well, what's something divided by the same thing always equal to? Yeah, and the signs cancel. In other words, the negative divided by a negative is a positive. So the tangent's positive 1. Okay, let's keep going. You have any more of these? Okay. Oh, hold on a second. Let me back up a second. Was that a minus angle? No, the last problem. Was it minus 5 pi over 4? I think it was. It wasn't? It was just they wanted the sine, cosine, and tangent of 5 pi over 4? Okay, I thought you read it with a negative and I worked the whole thing as if it was positive. It's liable to be a different answer if it's negative. Because negative 5 pi over was, okay, give me a negative one. All right, good. So, first of all, let's convert that to degrees. Pi over 3 is what? So what's 4 times 60? Minus 240 degrees. Same angle for all three of these. Minus 240 degrees. Now, we have a decision to make at this point. First of all, what quadrant is that in? Remember, negative angles start from the x-axis and go clockwise, not counterclockwise. So if you go 240 degrees clockwise, where do you end up? Which quadrant? How big is that? Oh, you can't see that. Okay. Let me know when you see the blue thing. You know what? We can talk about it. You don't need to see what I'm writing. What quadrant is minus 240 degrees? If I go 180 degrees clockwise, I get, what quadrant is it? Nope. If I start from the x-axis and I go 90 degrees, I get to the third quadrant. I'm in the third quadrant at minus 91 degrees. That's the third quadrant. So minus 240 gets you to where? Which quadrant? Tell me when you can see my screen, when you're back online. In fact, I'll go ahead and draw it, just so you'll have something to see when you see it. Okay. There's our 240 degree angle. Notice that to get from there to there is 180, right? 2 full quadrants is 180. So I got to go 180 and then 60 to get to a minus 240 degree angle. That angle is minus 240 degrees. Which quadrant are we in? Which quadrant? We got 4 quadrants. 1, 2, 3, 4. We're not in 3. Look at the picture. We went all the way from here to here. 2. Exactly. In other words, it's 90 degrees to get to there. It's 90 more to get to there. There's 90 more to get to there. So a minus 270 degree angle would be right there. This is only minus 240. Remember, we're going in the opposite direction. Positive angles go counterclockwise from the x-axis. Negative angles go clockwise. So we're in the second quadrant. Okay, so is all we really have to do. Let me erase all that so I have a little room to write. Now, what we really have to do here is, as long as I know we're in the second quadrant, well, I know what the plus or minus sign is going to be when I get done, right? I'm in the second quadrant. Sines are positive, cosines are negative, tangents are negative. So let's just figure out what the numerical part of the answer is. So what's the equivalent first quadrant angle of that 240? Okay, hold on a second. You can't really do it the way. Let me ask you this. Here's the way to do it. Turn it into a positive angle. What's the positive angle that equals minus 240? It's always the complement of 360. No, it's 120. In other words, these two have to equal 360, right? When you go 240, you'd have to go another 120. So it's the same thing. In other words, trig functions, you can do coterminals, and they're always the same answer. And by that, I mean, if the sine of 30 is 1/2, then the sine of 390 is 1/2. And I could add another 360 to that and say the sine of 750 is 1/2. So coterminal angles, 120 is the coterminal angle to minus 240. Because all I did was add 360 to minus 240, and I got 120. Okay? I'm going to leave that in brackets because that's not my equivalent first quadrant. What is the equivalent first quadrant? Remember, we're in the second quadrant. What's the formula? So, what's the answer? 60. That's what we want, is the sine of 60, the cosine of 60, and the tangent of 60. What's the sine of 60? What is its plus or minus sign? And the only thing we need to know is the second quadrant. We don't need to know it's minus 240 degrees. We just need to know what is the sign in the second quadrant. What's cosine going to be? of 60, first of all. Okay, now do the tangent by putting the sine over the cosine. Not multiplying by 1 over 2, multiplying by 2 over 1. When you divide by a fraction, you have to multiply by its reciprocal. If you don't multiply by its reciprocal, you're getting the wrong answer. So always know you have to take the reciprocal of the denominator and multiply it by the numerator when you're dividing. So it's really the same as multiplying it by minus 2 over 1. Right? What is that? Okay, you're doing these wrong. You're multiplying numerators, and then you're multiplying denominators. I don't want you to do it like that. I want you to cancel where you can cancel first. I can cancel those 2's out. I got 2 over 2 is equal to 1. So the answer becomes just minus root 3 over 1, which is minus root 3. There's your tangent right there. Okay? Now, that is one way to handle these negative angles. There are other ways, but until you get used to this way, I think I want you to work with this way. You haven't really learned yet that the sine of minus an angle is the same as minus the sine of the angle, have you? I mean, I've told it to you, but as your teacher, okay, if your teacher hasn't gone there yet, then let's do it this way, which is slightly harder. In other words, this way, I got to first of all convert that thing to a degree, and then I got to find its coterminal positive angle, which is 120, and then I got to find its equivalent first quadrant angle based on 120. So I got to do 3 things here. That's a lot of work. And then I got to take the sine of 60, I get that, and then I put a plus or minus sign based on the fact that it's in the second quadrant. I know signs are always positive in the second quadrant. So you have to figure out the quadrant, you have to figure out its coterminal angle, and then you have to figure out its equivalent first degree angle. So you have to do all of those steps on these negative angles. So let's do another one if you have another negative angle. What's that in degrees? Two pi is all the way around the unit circle once. Notice that halfway around it's pi, quarter of the way around it's pi over 2. All 4 quadrants is 2 pi. So that is the same as minus 360 degrees. Turn that into a positive angle. You can always turn a negative angle into a positive angle, or not always, but most of the time, the ones they're going to give you, just by adding 360 to it. Last time we had a negative 260. No, what was our angle last time? It was negative 240. We added 360 to that to get 120. That's always how you find the positive angle. Just add 360. If it's still negative, add another 360. You can just keep adding 360 until it becomes positive. So what do I get when I add 360 to this thing? To negative 360. Yeah, I'm dealing with a negative angle. So I got to, first of all, I want to turn it positive. Good. Now what's the sine of 0 degree? What's that? I like the way you're doing this. Let's just do it properly. You're looking at the coordinates on that point. What are the coordinates on that point? So what's the sine of 0 degrees? Remember, that is the cosine of that angle. That is the sine of that angle. So what's the sine of 0? Yeah, you can always figure these. These are called quadrangles. Quadrangles means they're multiples of 90. Okay? And you can't get those from those two triangles. So you kind of have to figure out a different way to memorize them. And the best way is this way right here, just to know all 4 of these coordinates. And know that the first coordinate is the cosine and the second coordinate is the sine. So that's 0, 1. That's -1, 0. That's 0, -1. So you can figure out the sine and cosine of your 4 quadrangles based on this picture on the lower right here. The most important thing to remember is that first x coordinate is equal to the cosine of theta. The second y coordinate is always equal to the sine of theta. That's on the unit circle and only on the unit circle. But on the unit circle, that's what it is. So by using this picture, which you can recreate this picture really easy, the only thing you have to remember is this stuff right here. Once you remember that, recreate the picture, and then you'll be able to answer what sine and cosine are for all of them. Ooh, hold on. Not sure what happened there, but okay. So what's the sine of 0? What's the cosine of 0? And I can go through the whole process also, but I don't need to, because I know that -2 pi is the same as 0. So let's just skip this part and go straight to 0. But that's 0 degrees. Okay. What's the cosine of 0 degrees? What's the tangent of 0 degrees? Yep. 0 divided by 1, which is 0. So there's your 3 answers. Hold on, I'm going to let my dog out. It's getting so hot in this office. She can't even stand it anymore. Go on. God, this will be the last hot day of the summer, I think. Should be. All right. It's even messing up my drawing tablet here. Okay, so what else you got? Either similar problems or other problems. I can give you the easy way to do those. You want me to show it to you? Might as well, because it really is the easier way of doing it. Yeah, I'll start it with the way they're giving it to you. They're giving it to you in radians, so I'll stick with radians. All right, let's do this one. Now, if I'm going to do it the hard way, and I'm going to do it the easy way. Okay? The hard way is -30 degrees. Equivalent coterminal angle is 330. Correct? Equivalent first quadrant angle is what? In other words, this is the same angle as that. It's 30. We are in the fourth quadrant. You're correct that we're in the fourth quadrant, but remember, we have to always get this down to a first quadrant angle. We memorized all the first quadrant ones. We haven't memorized the second, third, and fourth quadrant ones. We don't need to. You can always work them out. knowing, all students take calculus. So this works perfect every time. What's the sine of 30? Nope, that's sine of 60. Okay. And what is its plus or minus sign? Which quadrant are we in? Okay, so let's label fourth quadrant, so it'd be minus. Good. Now I'm going to do it the easy way. That's the hard way. Here's the easy way. The sine of a negative angle is equal to the negative sine of the positive angle. So we know what the sine of 30 degrees is 1/2. Carry forth that negative. That's much faster, is it not? I didn't have to go through this 330 degree angle back to a 30 degree angle. In other words, I actually eliminated 2 steps by doing it this way. Same thing for tangent. Tangent of a negative angle is equal to the negative tangent of the positive angle. It's the tangent of 30. I'll remind you, it's 1 over root 3. There's that negative sign. Bingo, that's easier also, much easier. Now let's look at cosine. Cosine of negative 30 degrees is equal to the cosine of 30 degrees. It's not the same as sine and tangent at all. That's odd. That's odd. That's even. Odd functions, the function of a negative x is the same as negative function of x. So for sine and tangent, these two are true. But for cosine, notice that the cosine of a negative angle is the same as the cosine of the positive angle. What's cosine of 30 degrees? Root 3 over 2. What's its plus or minus sign? Yeah, because it's cosine of 30 degrees. That's a first quadrant angle, so they're all plus. The only reason these turned out to be negative is because there's a minus sign in front of the tangent of 30, and there's a minus sign in front of the sine of 30. So doing it the second way, I did not have to remember all students take calculus. Don't have to know that. Never had to apply it. My plus or minus sign gets carried forth from step 1. What you do have to remember is that sine and tangent are both odd functions and that cosine is an even function. So there's one additional thing you have to remember, but you don't have to know really the unit circle. You do kind of have to know which quadrant you're in, because it isn't always as straightforward as this one right here, sine of minus 30. If I gave you the sine of minus 120, there's one extra step. You can still say that that's minus the sine of 120, but then you have to work with sine of 120, which means you take it back to a 60 degree angle, root 3 over 2. We know that we're in the third quadrant, so it's got to be negative. So there's 2 ways of handling negative angles. This is the way where you can just kind of crank through the process that I've taught you, where first of all you convert it to degrees, and then you convert it to a positive angle, and then you can give me the equivalent first quadrant angle, and then you go from there. This way is 2 steps less, but you have to know these first 3 aspects of, well, you have to know the characteristics of odd and even angles. Not odd and even angles, odd and even functions. It's not just trig functions that are odd and even. This function is odd. Excuse me, that function is even. Hold on, let me write it correctly. And this is the way I remember it, actually. That function is even. Well, what is that function? That is a parabola. Why is it even? Because it is symmetrical about the y-axis. Whenever you have a function that is symmetrical about the y-axis, it's an even function. Odd functions are not symmetrical about the y-axis. This is an odd function. And the easy way to remember on these polynomials is just look at the exponent. 3 is an odd number, 2 is an even number, okay? If I remember what this graph is, it looks kind of like this. Well, that's not symmetrical about the y-axis. That's symmetrical about the origin, which means if I flip it over the y-axis and then flip it over the x-axis, I get it. If I take this part of it from there to there and flip it over the y-axis and then flip it over the x-axis, I get what you're looking at to the left of the y-axis. That makes it odd. So that function is odd. In other words, if I want to write it like this, following me, y is the same as f of x. Odd functions have this characteristic. If I put a negative x in there, then they are negative f of x, which this is. If I plug in a negative x in place of x and cube it, I still get negative x cubed. So f of minus x is going to be minus x cubed, which makes it odd. Y equal x squared is even. You can certainly memorize these two because the exponent tells you whether it's odd or even. But the other thing is if you know how to draw these, then you can realize that even means symmetrical with the y-axis. Odd means symmetrical with the origin. All right, what else you got? I think we got another 10 minutes here, 5 minutes maybe. Okay. Five pi. Okay. Convert that to degrees. Pi is 180. Always remember that. Pi is the same as 180 degrees. Now convert that to an angle that is inside the unit circle. How do we do that? Right now, we're much bigger than the unit circle, right? When we had negative angles, the way I did it was I just kept adding 360 until I got a positive number. Well, in this case, you want to subtract 360 because I want to go down to the unit circle. Well, that gives me 540. That's still outside the unit circle. What do I got to do now? Subtract another 360. Remember, you can always add 360 or subtract 360 to any angle, and it does not change any of your trig functions. So the positive angle that they're talking about here is 180 degrees. And I can say that this is the equivalent of the cosine of 180 degrees. Same thing. So let's just write it like that. I'm trying to figure that out. Now, that's a quadrangle. What's the x-coordinate on that point? Visualize the unit circle. What's the x-coordinate on that point? Good. That's the answer. Simple as that. Do you need the sine and the tangent also on this? Okay. What else? Did you say sine or cosine? Sine of 9 pi over 4. I think for the time being, let's always convert these to degrees. You're going to get to a point where you are going to be able to think in terms of radians, and you won't have to convert them to degrees. But for the moment, let's convert them to degrees. What's pi over 4? No, just what's pi over 4? What angle is that? Okay, now multiply 45 times 9 on your calculator. How much? 405? Okay. Now what do we have to do? That's outside the unit circle. We've got to get it inside the unit circle. So what's that the equivalent of? In other words, if you have to subtract, you got to get it to an angle between 0 and 360. Well, the way you do that with this angle is by subtracting 360. If it was negative 20, you'd have to add 360 to it. So it depends. You do whatever you have to do to get it between 0 and 360. So when you subtract 360, what is that? Okay. So this is really the problem. What is the sine of 45 degrees? It's as simple as that. Just what's its plus or minus sign? First quadrant. All first quadrants are plus. Okay. What else? Okay. Let's just go ahead and translate that into degrees. It's pi over 6. This is the easiest way to do these translations. It's harder to do them this way when you go from degrees back to radians. When you're going from radians to degrees, this is without a doubt the easiest way to do it. Is to figure out what pi over 6 is and then just multiply it by 5. Okay, so that's the angle we're talking about. So let's start with sine. And they did say all 6 trig functions? Good. We haven't talked about the others yet, but that's fine. Okay, so what's the first thing I got to do to evaluate the sine of 150? What goes in the parentheses? The equivalent first quadrant angle. What is that? It is. Give me that number. Okay. What's the sine of 30? And what's its quadrant? So what is its plus or minus sign? I'm going to go ahead and put the plus or minus sign in on these. What's the equivalent first quadrant angle for cosine of 150? Nope. See above. It's the same exact process. In other words, just because we're doing cosine instead of sine does not change how you figure out the first angle equivalent. It's the same thing. It's 30. What's cosine of 30? And what is its plus or minus sign? Correct. Tangent of 150, which is the tangent of 30. When I say it's the same as the tangent of 30, it really isn't. It's the same numerical value as the tangent of 30, but we have to add the sine at the end. So first of all, what's the sine of 30? No, do it from putting sine over cosine. So flip the bottom, multiply it. Correct. Unrationalized, which is just fine. Is that plus or minus? Now in this case, you know just by the signs. In other words, if sine is plus and cosine is minus, and I'm dividing sine by cosine, the answer is minus. Okay? Now let's talk about the other three trig functions and we'll quit for the day. What is the cosecant of 150 degrees? It's just the reciprocal of the sine. It's the reciprocal of the sine. If the sine was equal to plus 1/2, then the cosecant is equal to plus, no, not reciprocal, not the negative. Reciprocal means you just flip the denominator and the numerator, so plus 2. Secant, which is the reciprocal of cosine, so we don't have to do anything here other than just flip that. Flip that in, what I've circled there. What is that? Flip it. Negative 2 over root 3. And finally, the cotangent of 150 is what? Okay, cool. Now, can you kind of see why you shouldn't rationalize it? Because if I were to rationalize that answer, what I just circled, the tangent, well, now, if I rationalize that, that becomes root 3 over 3. And then when I go to find the cotangent and flip it, I get 3 over root 3. Now I got to rationalize that, and I get 9 root 3 over 3. It becomes unnecessarily cumbersome to rationalize because so frequently we're taking the reciprocal. In other words, I don't want to rationalize 1 over root 3 because I know I might be wanting to know what the cotangent is. And the cotangent, when you flip them, it comes rationalized. So the cotangent is rationalized if the tangent is not. If the tangent is rationalized, then the cotangent is not going to be rationalized. So most trig teachers, they really don't care if you rationalize them or not. In fact, it makes more sense in trig not to rationalize them, because it creates additional work for you. So these three reciprocal functions, the way to remember them, first of all, you can always remember tangent goes with cotangent, right? Notice the other two both have one S and one C at the beginning. One C, one S. Which means you never have two S's. Secant is never the reciprocal of sine, because that would have two S's. You got to have one S and one C between the two of them. That way you can always remember them by using that. Because that truly is one of the harder things. For me, when somebody talks about cosecant, I have to first figure out, okay, that's the reciprocal of sine. First of all, it's not the reciprocal of cosine, it's the reciprocal of sine. And secant is the reciprocal of cosine. So once you get that down pat, then these all become easy, these cofunctions, or these, not cofunctions, but the reciprocal functions. All right, that's a good place to stop, Brandon. Thank you, and I appreciate you doing it a little early tonight. My fault on that, but works just as well. Yeah, I was going to say, you're probably happier with getting it out of the way earlier anyway. I will talk to you next time. Have a good one.